symmetry, and then average rate of change. That's the two things, what? Symmetry and rate of change. You don't need me to explain it? Do you know how to algebraically test for even and odd symmetry? Wow. I don't know how to do it. All right. So this kind of goes hand in hand with the Desmos that you did on Friday. We have two different kinds of symmetry that we're going to talk about. Yes, I'll put it in. I'll look at it. Yes, but we're going to call it even and odd symmetry instead of that. So reflectional symmetry is even symmetry. That's whenever it is symmetric, or we'll say this is, since y'all said reflectional. Thank you. That's why they pay me the big bucks. Symmetric about the y-axis, you call that the reflectional in the Desmos. We call it even symmetry here. So you can tell if a function is even if it splits it down the middle with the y-axis, okay? Examples of even graphically, maybe something like a parabola whose vertex sits on the y-axis is a terrible parabola. Okay. Anything that if the y-axis was a mirror that you held it up, that would be an even symmetry. Okay. About the y-axis, yeah. As opposed to odd, and odd is that rotational symmetry that we saw on Friday. If you twist it 180 degrees, it looks the same. 180 degree rotation, it looks the same. Y'all did pretty good with that, right? You understand what I'm saying? Yes, Miss McGee. No, Miss McGee. Which one was the one what? There's a sine or a cosine curve that we'll get to those. We'll get to those. Yeah. Yeah. Let me just, as a refresher, go back and show you. No, bro, I need them all. Why, Solomon? Some respect. Respect. Well, you're in a bit of a mood today. What's going on, Sullivan?
I'm not.
Are you having a bad day?
No, my day's been great.
Even the y-axis acts as an axis of symmetry there, and rotational. Notice that with the rotational, that point that it's rotating around has to be the origin. If it's anywhere else, then it doesn't work. Okay. This would be an odd function. The other would be an even. Odd is also reflectional. If you draw the line y equals x, we all know what the line y equals x looks like. Diagonal line through the origin, up 1 over 1, straight through. Odd functions are reflected over that line. So if I had that exact same, and well, it's hard for me to draw it on here. It's easier to see on the. If you were to draw that line, it would be reflected over that line as well. So that's another way to tell. All right, even versus odd. Can you tell? I'm not going to spend any longer on those two graphically since we did Desmos on Friday, as long as you understand how to identify both. Even versus odd, yes? Everybody okay? All right, let's talk about algebraically because that's the most important, or not the most important, but that's where your hard stuff comes in here. Algebraically, even versus odd. It's an easy concept, but it can get a bit sticky as you start working with it, okay? Here's what we're going to do. If we start with a function, we're going to call it f of x. Whatever it equals, it doesn't matter. If I negate every x in f of x, okay? So I change the sign of every x, and then I simplify it however it may be. If I get the exact same thing that I started with, even after I negate every x, that tells me that it's an even function. Can you think of a very basic function that this would happen with? X squared. Not plus 2x because the 2x would mess it up, but let's just stick just with x squared. Let's say f of x equals x squared. If I do f of negative x, so I replace the x, just the x, with a negative x. What happens when you square a negative number? It turns positive. Do you notice that these are exactly the same? That tells me algebraically that it's an even function. Even function, relational about the y-axis. Is everybody okay? That's a very easy example. They will not all be that easy. All right. Now, if I plug in a negative x and everything is opposite, that means I have an odd function. Rotational about the origin. Let me show you. Test that one and tell me, is it even, odd, or neither? Even, odd, or neither? What happens when you cube a negative number? Stays negative, right? Keeps the same sign. What do you think? Odd. See how every sign changed? In other words, I could have come here and put a negative in front of everything, and it would be completely opposite. So this one, that tells me this is odd. Completely opposite. Okay, so check this one. Even, odd, or neither? I heard odd. Anybody disagree? Or neither? All right, let's do the negatives and see what happens. The 2x squared, we said, is going to stay 2x squared. So we got 2x squared. What happens to the 3x? Okay, plus 3x plus 1. Even, odd, or neither? Is it completely the same? Like, is every single thing the same as what I started with? That's the same, but that's not. Is everything opposite? No, because the first one's not opposite, right? So this is neither. For symmetry, yes. You think this is hard? Did I say this was going to be hard? No, tomorrow we do all our must-know functions. This is easy today. Must-know functions. Could be even. The constant's just shifting it up and down, remember. That's a vertical transformation, so. What do you think it is? Odd. if I put a negative inside here, right, the cubed root of a negative is still going to be a negative. Everything's opposite, which tells me it's. How about this one? Even, odd, or neither? And actually, I'll even do this. Even. It's an even function. That's. All right, questions about symmetry before I do average rate of change?
Wait, how is that one even? Never mind. Wait, yeah, I got it.
You sure?
That is absolutely
Right, makes everything positive. All right, we'll taste of calculus here. Ready?
no.
You will see this is really easy, but we compare average rate of change in calculus to instantaneous rate of change on daily. So we start introducing you to the terminology here, but you'll see it's actually something you've done before anyway. All right, so average rate of change is nothing more than slope. It's not really another lesson. These are both kind of background stuff. Three. So what we do is we'll ask for the average rate of change, also known as AROC. Okay. Average rate of change between 2 points. So as a reminder, this is nothing more than slope. That's how we find average rate of change. We'll start getting into some word problems and things like that where you'll look at the rate that things are occurring and changing, and that will clue you in that it's nothing more than a slope problem, okay? That's all it is. So, going back, how do you find slope? Okay, so give it to me another way. Okay, so I'm glad you said it like that. I'm going to do delta y over, have I shown you all this before in Algebra 2? Delta means change. So it's the change in y divided by the change in x. Okay, you probably remember it being, there you go, the difference of the y's divided by the difference of the x's. Yes? You learned that slope has to deal with a line. It's the rise over the run of a line. And really, that's what we're doing when we do the average rate of change. We're connecting 2 points on a graph. For instance, y'all got that? Little trivia while I put this up here. What do you call a line that intersects a graph at 2 points? It's called a secant line. Intersects in 2 places. Tangent line intersects at just one, secant line intersects. So here's what average rate of change does. Average rate of change is the slope of the secant line between 2 points. That's all it is. So maybe I give you this parabola and I say, okay, y equals x squared. What's the average rate of change on the interval from 1 to 3? Here's what I'm going to do. What? Y'all said 2. You'll be given an equation, right? Let me come over here and start that. So maybe f of x equals, we'll just start using x squared. And I say, what's the average rate of change on the interval from 1 to 3? These are x values. That's exactly right. Secant line. Secant line intersects in 2 places. points. I'll give you a second to copy this, and then we'll go over to the. Y'all got this? All right, so look, this is my domain. Okay, think about that as the endpoints of the domain. They're restricting the domain. They're saying between when x is 1 and x is 3, what's the average rate of change, right, Charlie? So when x is 1, what is y? Don't let Charlie get one. He wants to play too. What is f of 3? 9. So now all I'm doing is slope between these 2 points. I've got the point 1, 1, I've got the point 3, 9, and I'm just going to do slope. Change in y, to get from 1 to 9, it goes up 8. To get from 3 to 1, it goes, or from 1 to 3, I'm sorry, up 2, so average rate of change is 4. Or think about it like 9 minus 1 over 3 minus 1. Say that again. Okay, so these, yes, well, no, these are both x values. That's not a point. That's saying on that range of numbers. So in other words, if I have y equals x squared graph, let's say, I know what that looks like. That looks like this, right? Here's the point 1, 1. Here's the point 3, 9. Find the slope between those 2 points, because this is going in between 1 and 3. That's telling me the range of numbers to look at. Does that make sense? Let's do another one. Let's say f of x equals x minus 4 over x. Find the average rate of change on the interval from 2 to 8. These are your 2 x's. I don't know, I haven't marked it yet. These are your 2 x's. So what we're going to do is we're going to plug each one of those into our equation, right? So we're going to find f of 2, and then we're going to find f of 8, and we're going to find the slope between these 2 points. Yeah. You plug both those endpoints in. That's exactly right. Oh, Slade, how did you know so quick? Oh, no, it's not. Pause. Oh my gosh. I quit. Quit. So my average rate of change, I'm going to subtract the y's, -1 minus a half, or a half, it doesn't matter, over 2 minus 8. -3 over 2 divided by -6. I'm going to multiply by the reciprocal because I don't have my calculator. I got 1/4. What y'all got? Yeah, it's fine.
You have to subtract it. It has to be
Always subtract.
the bottom.
Yes, well, what we started, yes, that'll always be that subtracted on the bottom. Oh, no, Moss? Find the average rate of change over the interval. I think I might not have given you enough of those ones with the graph on it. Yes, no, maybe so? Is that what y'all got? Yeah, four. I did 4 and 3 here. Um, it doesn't matter which one you do first, but whichever one you start with on the top, you have to start with that one on the bottom. So in other words, if I'd started with 2 up top, then on the bottom I'd have to start with -1. Because it's y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Does that make more sense? Yeah, so if I did it the other way, it'd be 2 minus 2 root 3 over -1 minus 7, which would be 2 minus 2 root 3 over -8. 1 minus root 3 over -4. But I could also I could leave it like that, or I could put the negative up top and say -1 plus root 3 over 4. Either one of those is fine. These are all the same thing. Yeah. You're supposed to have 2. One's got graphs on the front, and one's got average rate of change.
We have to do all of those.
Yeah, but they're quick. I'll show you. I'm gonna show you. All right, let me give you a word problem. Y'all thought we were just gonna skip Friday's lesson? Silly gooses. We did it Desmos. All right, let me go over a word problem because that's the most important part about AROC is getting you used to the word problems and how they go. Oh man, thanks, Sullivan. You want to answer it? Thanks, pal. Yeah. A company's total cost. Was that my sister? $. This one's not on there. To manufacture X unit is given by this equation. Okay. Find the average rate of change for the total cost of the first 200 units manufactured. So this is the cost to manufacture. You have one like this on your homework and your test, so I want to make sure I go to manufacture X units. I'll have to look. And the question asks you for the average rate of change for the first 200 units. Tell me what you think I'm going to do. I know I plug in 200, that's going to be right, but I need 2 points. So I can do C of 200, and I can get Y0. The first 200, so my starting point would be 0. My ending point would be 200, right? C of 0 is just 1,200. It costs $1,200 not to make any. That's just your startup stuff, I guess, your initial cost or whatever. And then I plug 200 in. I don't have a calculator on me, so somebody with a calculator do that. 0.05 times 200 squared plus 40 times 200. Yeah. What is it? Oh, he did it in his head. Yeah. All right, now find the average rate of change between those 2 points. Whoever said that is 100% correct. And we got to get the units right. Units on here are going to be half your credit on the problem, so make sure you get it. What is it, 5? 5. $50 is only half the answer. It's 50 what? Not units. We're talking about rate of change. Dollars per unit. If you manufacture 200 units, you spend an average of $50 per unit to make them. If I change that 200 to something else, it would change the average. Do you see what we're doing? No, that's not the actual cost per unit. That's the average over the course of 200 units. Does that make sense? All right, I'll let you get started.